So this idea of convergence that we introduced in chapter 8 is closely tied to the idea of a limit. Okay? A limit is when we say that it is actually converging to a particular number. But you can talk about convergence without talking about that it converges to something particular. You can just say has convergent behavior. That means it's falling in line with something, it's coming alongside of something without actually defining what that something is. And then the opposite of convergent being divergent, okay? Separating from the norm, something that's not conforming. We're now gonna be talking specifically about something called a series versus a sequence. So that's our first goal today, is to dabble in, okay, what was a sequence? And if we understand what a sequence is, then we'll be able to understand what a series is and the difference between the two. Okay, all right, here we go. First 4 terms of the sequence. So we know that these are explicit sequences generated by plugging in what numbers? Consecutive starting where?
At a starting point.
Which starting point? 1, yeah. Okay, so these are explicit sequences. They always start with the term of 1, and you'll indicate it with the brackets. So if we are looking for the first 4 terms, okay? So Christian, get us the first term, Juliet the second, Rain the third, Alex the fourth, and then Kaylin, if you can be working on the 30th. Okay? So it should be pretty quick. All right, Christian, first term? 4 thirds. Thanks. Juliet, second term? 1. Can you give it to me in its non-reduced form? Okay, thanks. All right, Rain? 4 bits. Okay. All right, great. So yeah, specifically asking for it in its non-reduced form, it will be easier for you to see patterns if you don't reduce it right away, because then you can consistently see what the pattern is, as opposed to if we set it in its reduced form, it would be 4 thirds 1, 4/5, 2 thirds. It's just not quite as obvious what the pattern is when it's written in reduced form. So usually while we're working on it, we leave it in its non-reduced form. All right, and then jumping to the 30th, Kaylin?
4/32.
Okay, good. And so again, he could have said 1/8, but he gave it to me in its non-reduced form. All right. Okay, Edson and Jonathan, you're up. Okay, first 4 terms. Okay, all right, Edson, give me the first 2.
Negative 1/2, or not negative 1/2, negative 1 and then 1/2.
Okay, negative 1/1, positive 1/2. Okay, Jonathan?
Negative 1/3 and positive 1/4.
Okay. All right, and if we jump to the 30th term, what kind of numerator will we have? Positive. Okay, so this is a positive, and the denominator will be 30. Okay, a equation that has this kind of property where you're going positive, negative, positive, negative, positive, negative, positive, negative, okay? This has a special name, so I'm going to use this a lot over the course of chapter 9, and so we want to call this an alternating sequence. The word alternating means the sign is flipping back and forth, and you can recognize that by what particular part of the equation? The negative 1 to the n power. Anything that has that particular form in it, no matter what else is in there, as long as it has that form in it, it will be generating what we call an alternating sequence. So you'll need to be able to start learning to recognize that, because alternating sequences are going to have special properties. And so you need to be able to, oh, that's going to alternate. And you just recognize it because of that term. So the term negative 1 to the n. Okay, those are sequences. So what's the difference? A sequence is a list of individual terms. So A1, comma, A2, comma, A3, comma, A4, comma, dot, 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 all the way up to AN, A sub n plus 1, A sub n plus 2. It is simply a list. A series is also a list, but the lists are not individual terms, the lists are individual sums. It is a cumulative sum. So in a series, oh, here we go, sorry. This should be bracket A sub n, all right? So bracket A sub n would generate a sequence. Summation A sub n is going to generate a series. And these are what we call cumulative sums. So you're going to have sum number 1, and sum number 2, and sum number 3, and sum number 4, etc., all the way up to sum sub n, sub n plus 1, sum sub n plus 2, etc. In these two lists, there are two terms that match exactly from one list to the other. Any idea what those two terms are? The first one, okay? The first two terms are equal because the sum in that one is only one term to add. But by the time you move to sum number 2, that is generated by A sub 1 plus A sub 2. So it's the sum of the first two terms, bless you. And then the third one would be A sub 1 plus A sub 2 plus A sub 3. So we're adding the value of the next term. And then 4, and then 5. So these are progressive sums. Does it follow, would it be a true false statement, or would it be a true statement to say that the sums always get bigger? No, why? Okay, adding a fraction is still going to make it bigger. I could be adding negative numbers, okay? And so my sum doesn't always get bigger. Sometimes it gets smaller. But what happens if you add a negative number, and then a positive number, and then a negative number, and then a positive number, and then a negative number again? It depends. It depends on how big the negative numbers and positive numbers are, okay? That's our whole goal, is to find out what is the sum itself. Is it diverging? In other words, it's just growing big and getting bigger and bigger and bigger and bigger. Or is it alternating also? Is it getting bigger and then smaller? And as it alternates, does it still diverge? Or as it alternates, does it converge to something? That is the whole purpose of this particular lesson, is to find out if series themselves diverge or converge. So we're going to, what did I do here? Oh, nuts. Okay, so finding the first, we just want to compare and contrast the first 4 terms of the sequence. All right, so starting with the sequence, all right, we'll have Kaylin, then Alex, then Rain, then Juliet, okay? First term, Kaylin?
1 over 2.
Good, okay. Alex, second term?
1 over 4.
Okay. All right, what, Rain?
1.
1 over 8, and Juliet?
1 over 6.
Okay. So these individual terms are getting smaller and smaller and smaller. This sequence converges. And what will the sequence converge to as we progress and maybe we went out to infinity? it will converge to 0. That means the terms are getting smaller and smaller and smaller and smaller. Okay, now what about the sum? Okay, well, we know the first term is the same. Okay, Christian, can you give me the next value?
3/4.
Okay, 3/4. Okay, Jonathan, how about the next one?
7/8.
7/8. Okay, Edson, how about the next one? 15/16. Very good. All right, are these getting bigger or smaller? They're getting bigger because 1/2 to 3/4 is bigger. 3/4 is larger. 7/8 is larger. 15/16 is larger. All right, are these, just because they're getting bigger, does it mean it's going to get bigger to infinity? Okay, is there a limit to how big it's going to get? Okay, so let's express it in numerical terms. What would the nth term be of any n? Okay, is it 1 over? Okay, so let's look at the denominator. What will the denominator be? 2 to the n. Okay, what will the numerator be related to that denominator? 2 to the n, and then 1 less than that. Okay, so that's the general expression for this series, okay, as our added progressive terms go. But Alex, you were right, this does have a limit. And what does it converge to? It converges, it will never be larger than 1. It will be close to 1. We'll get closer and closer to 1 as we go. We'll be 127 over 128. Okay, and then we'll be 10,027 over 10,028. We'll just keep getting closer and closer to a value of 1, but we are converging to 1. So the series converges to 1. So even if a sequence converges to 0, the series will converge to something different. It's not a zero sum. All right, let's get the first 4 terms. I forget where we left off, so Christian, we'll just have you start.
5/10.
Okay, 5 over 10. Now, leave it. Yep, leave it like that. So 5 over 10. All right, Juliet?
5 over 100.
Mm-hmm. Okay. Alex?
5 over 1,000.
Uh-huh. Okay, and then 5 over 10,000. So the generic term would be 5 over 10 to the n. All right, so the sequence is converging as they get smaller and smaller. What is it converging to?
0.
Mm-hmm. All right, but what about the sum? All right, what will the sum converge to? All right, now interestingly, I want to think about actually our sum in terms of decimals. So I think you're going to see it a little more quickly. All right, so the first sum, if I'm just going to express it as 0.5. Okay, it's the same as, all right. Now, the next sum, okay, so Kaylin, add that to the next one.
These are 0.55.
0.55. All right, Edson, next one.
0.555.
Okay, 0.555. And then Jonathan would come up with 0.5555. Does anybody know what that converges to? What 0.5 repeating converges to? Yeah, a repeating decimal, you could put 9 in the denominator. So if it was like 0.222222222, that's 2 over 9. That works for any decimal. Okay, so what if you had like 0.131313131313? then it's 13 over 99. Okay, so if you have 2 decimals repeating, then you need 2 nines. If you have 6 decimals repeating, you need 6 nines. So this converges to 5/9. So the series converges to 5/9. So that's just a little math sense, or like knowing how fractions work. All right. All right, so we see the alternating series. So if we just sequence, excuse me, if we just write our sequence, we're going to have -1, 0, -1, 0, -1, blah, blah, blah.
Isn't it one?
I mean, da, 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 da. I'm thinking ahead to the next one. I just gave it away. Okay. Is there a pattern? Yes. Does this converge?
No.
Okay. This does not converge. Does it diverge? No, because it is predictable. So this is simply not neither diverging nor converging. It's simply alternating. Okay? All right, so let's talk about the sum. All right, so the first term has to be the same. Then if I add the next term, what do I get? 0. That was what I was doing already. Then if I add the next term, what does it go back to? And then 0, etc. Okay? So this also is an alternating series. It does not converge. Predictable, yes. Convergent, no. By definition, something that alternates, although is a category of divergent behavior, simply because it's not convergent. If you're not convergent, you're some form of divergent. This is a special form of divergency called alternating, which is, again, going to have separate additional properties as we go throughout the chapter, but I want you to get used to recognizing that. All right, there is another kind of series called telescoping series. A telescope, if you extend it, the built-in lenses will allow you to see farther the farther you extend the lenses. But the way it's designed, it also is collapsible, and those things slide into each other and collapse back down again. The idea of collapsing, we could have called these collapsing series, but they were named telescoping series because you expand them first, and then you collapse them back down once you've recognized the pattern. So I'm going to teach you about this category, but that's the name, and that's why they're named that. All right. So before we can look at this series, we want to look at the sequence. We want to come up with the different terms so that we can figure out if we can notice some kind of pattern to this. So I'm actually going to go a little bit up, and I'm going to do just the sequence first so I can have an idea of what's happening here. All right, so Jonathan, can you get me going on my sequence?
1/2 is the first term.
Okay, so it's 1 over 1 times 2, which is going to be 1/2. Okay, Edson, next one.
1 over 6.
Mm-hmm. Okay, Kaylin.
The 1/12.
So 3 times 4. Okay, Rain.
1 over 10.
Uh-huh. Juliet.
1 over 30.
Okay. All right. Now, if you want to grab calculators because you want to be able to see the sums here, let's take a look at these sums now. All right. So the first one is half. I can do that. All right. Christian, can you do the next one? So we've got, and actually in this one, I am going to reduce it to 2/3. Okay. All right, Jonathan, next one, 2/3, and we're going to add a 1/12 to that.
3/4.
Good. It's 9/12, which is 3/4. All right, I'm starting to see the pattern. Edson, does it work for the next one?
Yeah, 4/5.
Okay. All right, because did you get 16/20?
Yeah.
Okay, great. So we can start to see, oh, this is starting to look like maybe this is going to be approaching a particular value. All right?
5/6.
Okay. All right, so this is one way. I just kind of call this the brute force way of just, it's just literally you got to find all the terms and then you got to find all the sums and then see if you can figure out, okay, this looks like it's converging, it looks like it's converging to 1. But I want to show you a different way that when you have something that's in this format with two factors in the denominator, what does that remind you of in that format? Anything from last chapter? When you have something written like that? Let's see if this rings a bell. Okay, does that ring a bell? Okay, so partial fractions. All right, anything that's written in with two linear factors in the denominator can be separated out as a partial fraction. If you don't mind, I've already done the partial fraction work. You guys are comfortable with that, right? Does anybody need a crash course in partial fractions? Okay, well, it works out to be this. 1/n and -1/n plus 1. Okay, why is that useful? All right, well, let me show you. If we replace the sum with its partial fraction form of 1/n minus 1/n plus 1, the pattern reveals itself really, really quickly. Let me show you what happens. All right, so plug in the number 1. All right, so Rain, what do we get? Starting with number 1.
It would be 1 minus 1/2.
1 minus 1/2. All right, now we're going to add to it the next term. So we're going to plug in the number 2. Okay, Alex, plug in the number 2. What do you get? 1/2 minus, not 2/3. Not 2/3. The numerator's not 2. 1/3. Okay. Juliet, do term 3.
1/3 minus 1/4.
Okay, Christian, do the next one.
Plus 1/4 minus 1/3.
Okay. And you could predict what would come next. The next one should be positive 1/5, negative 1/6. And then positive 1/6, negative 1/7. And then it's just going to go. We call this telescoping because what happens is after the number 1 starts, then these two terms have a net sum of what? 0. And then these two terms have a net sum of 0. And then these two terms have a net sum of 0. And so as we approach an infinite number of terms, every term will collapse with its term that you pair it with previously, leaving you with only one term left, which was the very first term that you started with. The only one that doesn't have a collapsing pair is the first one. And so as this starts, as the telescoping happens, the answer to that is 1. Now I showed you this in an example where you could have done it both ways. You could do it by literal, just brute force and work it out and say, oh, I see that, the first way, the 1/2, the 2/3, the 3/4, the 4/5, you can see that it's happening there, but sometimes it's not obvious. And telescoping allows the convergence to reveal itself because of the way terms collapse and cancel each other out. All right, so this is our last example. So Christian, can you give me this one? I remember it's a 4n plus...
The denominator is 4n minus 3.
the numerator is just 1?
4.
4. Okay.
4
4n.
minus 3 and then minus 4n plus 1.
Okay. So because this has 2 linear denominators, I start to suspect, I wonder if this is going to telescope. I only suspect that because I can look at it from linear fractions. So do a little algebra where A would be over 4n minus 3 and B would be over 4n plus 1. And again, I've already worked it out. Okay, and it's 1 and -1 again. So I already worked this out. So I can replace this sigma with 1 over 4n minus 3 and -1 with 4n plus 1. And then we want to look at what's going to happen to these terms. All right, so Juliet, Christian, you never told me. I'm assuming it's 1 to infinity?
Oh, yeah.
Okay. Okay, so Juliet, let's get me the very, very first term.
It's 1/3 minus 1/5.
Is it 1/3?
Oh, sorry, 1 minus.
Okay, 1, and then minus 1/5. Okay. All right, Rain, give me the next one. Plugging in the number 2.
1/3
Careful, we're plugging in the number 2.
1/5
Okay.
minus 1 over 9. Or no,
Yeah. Okay, Kaylin, give me the third term by plugging in the number 3.
1/9. And then 1 over 13.
All right, and then it's going to be 1 over 13 minus 1 over 17, and then ... So again, the telescoping nature of these linear factors. Okay, I'm going to have consolidation to where the terms are going to collapse onto each other. And of course, the 1/17 would eventually collapse with the next term, on and on and on. And so this also has convergent nature to be converging to a sum of 1. The individual terms alternate. Alternate. But the sum converges to the number 1.